Well, welcome. Thank you for being here. Good to have you. Get yourself ready with a notebook, a pencil, or a pen. Whichever you choose to write with is fine. This is math from the void. Math coming at you out of nowhere. And today we've got a very clean-cut, straightforward problem from the 2004 AP Calculus BC exam. Now, despite it being from the BC exam, this is completely approachable from an AB student. So, honestly, let's just ignore that it says BC on it, because it might have very well been on the AB exam. I wouldn't be surprised if it was also on the AB exam. If you're an AB student, don't be scared. You can do this. There are no BC specific topics required or techniques. So give yourself about 10 to 12 minutes, maybe 10 minutes if you're in Calc BC. This should be your bread and butter. If you're in AB, I'll give you a little more time. And then when you're ready, come back, join us as we venture through the void, and you can see how it's done here. All right, let's get it cracking. So we're given a curve, not a function, but a curve defined by this equation. And we first want to show that the dy dx, the derivative of y with respect to x, is this expression here. So we just have to do some implicit differentiation, right? So we're going to have 2x plus 8y dy dx. So when we do implicit differentiation, we're literally just replacing y with some kind of function. And so we have to use the chain rule. And on the right side, we have this product. The derivative of 7 is just 0, so of course that goes away. We have this product here, so we have to deal with that carefully. Derivative of that product is just going to be 3y plus 3x dy dx. And now we can group terms together. Let's get all the dy dx stuff together. I'm going to move the dy dx stuff that way, and then I'm going to move the 2x over here. So my dy dx stuff, we could just factor out dy dx. My dy dx stuff includes 8y minus 3x, and on the either side, we have 3y minus 2x. So, pretty simple, straightforward. Part A is very much a breeze, just kind of getting you used to taking some derivatives, flexing those basic derivative muscles. You know, you had a product rule in there, but that's not too bad. And then we just isolate dy dx, okay? So, just algebra on steroids. That. Let's take a look at part B. We also want to show that there is a point. Okay, so we're looking for an xy with x-coordinate 3, at which the line tangent to the curve is horizontal. That is telling us something very important. Line tangent to the curve has a slope of dy dx, and if it's horizontal, that slope is equal to 0. So they're basically telling us when x equals 3, then dy dx equals 0. We need to show that that is true. Find the y-coordinate of point P. Okay, so what we can do here is we can use x equals 3. See the expression for dy dx is now going to become 3y minus 2 times 3 over, doesn't really matter too much what's on the bottom, just as long as 0 is not also on the bottom, 8y minus 9. We need this to equal 0, which means we essentially just need the top to equal 0. And therefore we would need y to be equal to 2. Now let's make sure that that point is actually represented on the curve. Like, we got to make sure of that. Because yes, this x and y value would create the slope of 0 for the derivative, but that is already presuming that it's on the curve, so we haven't verified that. So let's just make sure that if we plug in 3 for x, and if we plug in 2 for the y, that this will indeed be equal to 7 plus 3 times 3 times 2. Fair enough. So we're going to have 9 plus 16, which is 25, if you're so inclined to simplify that. 7 plus 3 times 3 is 9. 9 times 2 is 18, and 7 plus 18 for sure is 25. So we have verified that there's a point, P. Specifically, it's 3, 2. So we say y equals 2. Right, so we did have to justify that this value is on the curve. We use the fact that its tangent slope would be 0 because it's horizontal to figure something out about what the y must be, but then we have to check that the y can actually be that value. We don't know that for sure. All right, part C. Rushing through these like lightning. Find the value of the second derivative, d squared y dx squared, at the point P, found in part B. Okay, so we have to find the value of this with the point we just found. So we need to take a derivative of the derivative, and then it's also asking, does the curve have a local max, local minimum, or maybe neither at the point P? So first we have to take a derivative of dy dx. So this is going to be the quotient rule, right? You guys know the quotient rule? Different ways to remember it. Some people do the sing-song, low d high minus high d low. So the derivative of the top, which is going to be 3 dy dx, and don't worry about the fact that dy dx is in all of these expressions, minus high d low. Yeah, don't worry that dy dx in these, because we're going to have the value of dy dx. Isn't it 0? Yes, it is 0. So high d low is going to be 8 dy dx minus 3. And don't forget to square down below. 8y minus 3x squared. So I guess in a sense it was helpful that we were plugging it in. Down here we didn't really plug it in, but if we got y equals 2, that means the denominator there would be 7. That's going to come in handy. Just you wait and see. This is the second derivative. Now, if you didn't get the correct point from part B, it's obviously going to be tough to get full credit on part C. But if you plug in the point correctly, even if it's a wrong point, they will give you some credit for using the point into the correct derivative, assuming you took the derivative of dy dx correctly. Yeah, if you did that correctly, a few assumptions are happening there, I understand, but what I'm saying is that if you use past wrong information on the questions that are coming, and you use the wrong numbers but in the correct way, you could still be awarded credit for that. Because from that point, despite the calculation error, you're thinking about this correctly. Okay, so let's remember that at the point P, that means x equals, or that means we're talking about the point 3, 2. And so we can plug those values in, but remember that dy dx at that point, since the tangent line is horizontal, dy dx equals 0. So this goes to 0, this goes to 0, it's kind of nice. And then 8y minus 3x, that just equals 7 times negative 2, minus 3y minus 2x. Of course, that is also going to be 0. That whole thing is going to be 0, right? 6 minus 6. And then we have over 7 squared. So it looks like we just get negative 2 over 7. That's the value of the second derivative at this point. And what this means is that there's a flat point on the curve. So dy dx equals 0. And the second derivative is negative. What does that mean? That means that the graph is concave down, kind of like a sad face. And the flat point is therefore a relative maximum. Right? The flat point is where the derivative equals 0. Wow, those are some really bad horizontal lines. That one's a little better. Okay, I'm satisfied enough. This means that the point here is a maximum. So we can say that a curve has a relative max. I guess I'll just put the point at 3, 2. Okay. Relative maximum, local maximum, tomato, potato, potato. Same thing. All right, so we get some points on that part for doing the derivative correctly, plugging in the point and getting a value, So you probably wouldn't get the right value if you plugged in the wrong numbers, but you would still get credit for like plugging it into this. And then if you have a justification for your conclusion, even with your wrong number, you might get awarded a point. Like if you got a positive value because when you plugged in the incorrect number from part B, you ended up with a positive value, like the justification could possibly get you some kind of a point. I'm not guaranteeing this, I'm not one of the graders, but I just want you to consider that like working diligently, even if you don't have 100% certainty that you're using the correct numbers, just trust the math, and it definitely can't hurt you unless you contradict yourself in the argument, in which case you shouldn't say like the derivative is positive and then also the derivative is negative. That won't help you at all. But I just mean that writing thoroughly and thinking through the calculus thoroughly without any numbers is doable, and it's rewarded. All right, I think that's enough blab out of me because this problem was so straightforward. But I'll see you guys next time in the